Okay guys, so in this video, I'm going to show you guys how to use the 3x3 table to help you set up more complex similar right triangle problems. So we're starting out highlighting the small right triangle, right? The small right triangle. And the short leg is right here and it's labeled Y, right? So I would put small right triangle, short leg, Y. And then I move on to the long leg. The long leg is this segment and is Z. Okay, so I put Z underneath long leg. And then the hypotenuse of this small right triangle is blank because I don't know what it is. All right, and then I move on to highlight my medium right triangle, which happened to be the one on the other side, this one right here. And the medium right triangle have the short leg, which is right here, okay? This is the short leg of the medium right triangle, and it is Z. So I put Z down here. And the long leg happened to be X, as they label it right here, X. This is the long leg, okay? So X. Now, the hypotenuse of the medium one is actually given to me. It's 14, so I do want to write that down, okay? And then now, finally, I am going to move on to my large triangle, simply because I look at this information that I have and I say, okay, this is a proportion, but there are too many variables in there. I don't know how to solve that. This is a proportion, but there's some missing information here. So there's so much going on that I still don't have what I can use to solve. So I'm going to move on to my large triangle, which is the one on the very outside. So I'm going to use blue to highlight that whole entire thing right there, okay? So now the short leg is over here. And again, I don't have that information. So the short leg of the large triangle is blank. And then the long leg of the right triangle that's outside is this one right here and happens to be 14. Okay? And then the hypotenuse of this large triangle happened to be 16 as given to you right here. Okay? So I would put 16 here. After I do this, I can see right here is my proportion. Okay? So I would go down and I would write this proportion and I would solve for X, right? And technically, you don't even have to write down the proportion because it is a proportion as is written. So you could actually do X times 16, 14 times 14. So you would have 16X equals to 196 because 14 times 14 is 196. And if I take 196 and I divide it by 16, I would get X equals to 12.25. Okay, and the minute I find an answer, I want to put it back in here, okay, so that I could use it to perhaps help me solve some other missing segment. Okay, so I put this 1225 back in here, and I also put 1225 back in here. Well, the problem tells me that the whole thing is 16, and X is 1225. So that actually helped me solve for Y. So not necessarily the table, but once I find this information, I can go and say, oh, well, you know, if I take 16 and I take away 1225, that would give me the value for Y. And that happened to be, what is it, 1225? No, it's 16, 1225. Oh, I can't do my math. It's 375. So it's 3.75. It's that one. And then now that I have a value for this and a value for this, I can certainly use a proportion right here to solve for my Z. So it's going to be Z times Z, which is Z squared, equals to 3.75 times 12.25. Okay? Let me draw a line so that you don't get confused with the other problems. And I multiply these two values together, and I get Z squared equals to 45.94, rounded, right? And then I would take the square root of this. I take the square root of this messy number. I would get Z to approximately 6.78, rounding into the